this webinar today on the stainless steel finishes. We know of stainless steel that it resists corrosion or stains in general. Stainless steel has a function which builds around a certain resistance to stain and corrosion as a primary function. But at the same time, we should know how to use stainless steel in terms of right grade, design, fabrication, and finishes. Otherwise, the users can have some avoidable disappointments. These disappointments tend to fall into only a few basic categories, but it is critical that we understand the possible causes which lead to such a situation. In most cases, a little basic knowledge would have prevented or significantly improved such a situation. In this context, there are several good reasons for paying close attention to the finishes. In architecture or other highly visible applications, the appearance of stainless steel is a critical design element, and a misunderstanding or the wrong finish can alter the desired effect. In consumer products such as appliances, cookware, and automobiles, the gleam of well-polished stainless steel has strong sales appeal. In commercial equipment such as used in institutional kitchens, restaurants, and hospitals, properly finished stainless steel helps to emphasize the feeling of cleanliness. So today's webinar is designed to help designers and specifiers achieve better understanding of stainless steel finishes so that the desired service conditions are met without any adverse impact. The webinar is being presented by our eminent speaker, Catherine Hoeska, will discuss the factors that affect finishes appearance, guidance on section of finishes, and alloy for various type of applications. This webinar is brought to you with the help of our partners, Nickel Institute. Georg is here today, and International Molybdenum Association. So I'll hand over to Georg for telling us a little more about Nickel Institute and International Molybdenum Association, and also give a formal introduction to Catherine. Over to you, Georg.
Thank you very much, Karan, as well for the nice word. I will now share the screen. Voila. Okay, I hope you can see the screen.
Okay. Yeah, it's visible.
Well, yes. Perfect. Welcome to everybody. Thank you very much for taking the time to join this webinar. Quick introduction of myself. My name is Jörg Schweitzer. I'm the manager of the market development team in the Nickel Institute. So, as such, based in Singapore, but as Karan mentioned, at the moment staying in the US. So for Catherine and me, it's pretty early in the morning, but we are more than happy to do that for everybody. So let me quickly introduce the Nickel Institute. We are a global association of the leading primary nickel producers. Our mission is to promote and support the proper use of nickel in the appropriate applications. The Nickel Institute grows and supports markets for new and existing nickel applications, including stainless steel, and we promote sound science, risk management, and socio-economic benefits as the basis for public policy and regulation. As you know, nickel is a key element in more than 75% of all stainless steel produced, delivering these outstanding physical and mechanical properties, and makes stainless steel such an attractive, easy to use, and durable solution. We are located, the headquarters in Canada, Toronto. We have an office and a research lab in Durham, the US. Then we have as well the European headquarters in Brussels. We have incorporated non-profit organization in China, in Japan, and we have rep offices in Singapore and in Australia. To IMOA, International Molybdenum Association, they are as well a non-profit global trade organization. It presents the majority majority of the molybdenum industry members globally. IMOA promotes the properties and sustainable benefits of molybdenum use in the wide range of modern-day applications. So molybdenum is the key alloying element in stainless steel and nickel-based alloys, providing as well improved corrosion resistance. And now to the most important person of the day, that is Catherine Huska. She will pretty soon start with her presentation. She is the president of her own company, Catherine Huska Consulting LLC, and as well, she is a consultant to us, to the Nickel Institute. Catherine is an internationally recognized expert on architectural metals, speaker and author of over 200 publications. She consults internationally for some of the world's most well-known architectural and engineering firms, as well as for building owners, metal finishing firms, producers, and fabricators. She's well versed in the ASTM and the Euronorm standards for stainless steel finishes, is a long-term member of the US Green Building Council and chairs the ASTM's General Sustainability Standards. She has written numerous publications about stainless steel finishes and has significant experience in consulting for finish suppliers to improve their products, developing project specifications, and as an expert witness when finish problems occur. You see, highly qualified for today's talk. Catherine, I would like to hand over to you. Thank you.
I'll just add a word. I'm sure the delegates will have some questions. Please put your questions, which we will take it in the end. Thank you.
Catherine, I think you are muted. We can't hear you. Nope. Nope.
All right, can you hear me now?
Yes, now we can
Great.
hear you.
I'm not sure what's happening with my headphones. Apologies, everyone. Thank you for attending my webinar. I wish I could be with you in person. I really enjoy going to visit India. And today we're going to talk about advanced specification of stainless steel finishes. The image that I'm showing on the screen is of the vessel at Hudson Yards, which is one of the projects I've consulted on over the years. I did want to mention that everything that I am saying is a suggestion for your consideration. I don't make recommendations when speaking for the industry associations, but we are happy to provide advice. So the first steps in achieving aesthetic success are first understanding the service environment, because we want to avoid damage from corrosion. But also, we have to consider how human beings will interact with the surfaces, whether it's a building panel or an appliance or whatever the product might be that a finish is applied to. You have to consider whether it's likely to be scratched and damaged, or if impact is likely. because all of that can affect the appropriateness of a specific finish. If it's an exterior application, weather conditions have to be considered as well. If they're likely to be wind-blown abrasives, then you don't want a finish that where that would remove a color or change the finish irreparably. It's also important to determine the appropriate stainless steel chemistry specification. And I'm going to talk a bit more about that, as well as some of the different finish options. And as I talk about each, a bit about the maintenance requirements. So to start with, the factors that influence corrosion are, first of all, pollution, particulate accumulation. If you have dust settling on a surface or leaves that might be sitting on a roof, that creates crevices. Weather conditions play a role too. If you have regular heavy rain, then that does a wonderful job of washing surfaces that are exposed to it. But if you tend to have high temperatures and high humidity and salt exposure, then that's a much more corrosive environment. Maintenance, if it is done on a regular basis, can allow you to use a less corrosion-resistant stainless steel and permit finishes that might not otherwise be possible. Aspects of design, like the presence of crevices and your finish, also affect the appropriateness of a given stainless steel. We'll talk a bit about surface finish texture and roughness and the role it plays, and handling and fabrication also play a big role. And there are many brochures available on these topics. And I'm simply mentioning the fact that you have to consider them, but I'm not planning to delve into them in depth. I briefly want to make you aware that there are many different stainless steels. I've shown a few here just to show the range in the level of corrosion resistance that is possible. The PREN number is calculated based on the chemistry of the stainless steel. The calculation that is used varies with the alloy. I'm showing one of those formulas so that you have some idea of how we make a calculation. This is a relative level of corrosion resistance. It's the level can vary with the specifics of the environment, but I'm showing everything from 17.4 pH martensitic stainless steel, which is barely a stainless steel, and often used for things like fasteners. Then 304, duplexes like 2304, 316, which all gradually increase in corrosion resistance, going all the way up to stainless steels that can be immersed in seawater and used in very corrosive industrial environments. So we have a range, and it's important to select the appropriate stainless steel for that range, and you can obtain guidance from the experts at ISDA. As it relates to finishes, if you have a finish that a special finish like electrochemically colored stainless steel, as I'm showing in this image, and you pick the wrong stainless steel for a service environment, the color can corrode away. Abrasion of the surface can do that too. This was originally a green stainless steel shingle used for a roof. It was near the coast. Those little white spots are salt and sand from sand dunes that are sitting on the surface, and it was so corrosive that the stainless steel has started to lose that color. And that's part of why we want to be very careful in selecting the right alloy. So austenitic stainless steels can have every finish I'm going to talk about today, and others, because I can't cover all possible iterations in this presentation. The ferritic stainless steels, or often called the 400 series, have fewer options than the austenitics. So, for example, the image I'm showing on this slide is electrochemically colored ferritic stainless steel. And the only color that you can obtain is gray. And it's this essentially a medium tone gray. Well, austenitics and duplex stainless steels can have a full range of electrochemical colors. Both the ferritics and the duplexes have fewer mechanical and coin finish options than the austenitics. And there are other limitations too. It will depend on the specific finish you are trying to obtain. So it is important to talk to suppliers to determine which stainless steels are an option for the finish you're considering, and how that finish might vary from one alloy family to the other. I should note that each stainless steel family has different mechanical and physical properties. There are different levels of formability and weldability. So there is more to consider, but that's not the topic of this presentation. When it comes to specifying finish, there are some basic things that I want to make sure are discussed. The alloy should be specified to an internationally recognized standard, whether that's ASTM or EN or GIS or whatever that standard happens to be. It is important that you not just say that you want, for example, 316, but not call out a specification. That's an important means of communication with the stainless steel supplier so that they know what your needs are. As I mentioned, you do need to consider corrosion resistance, but also the level of formability that you want in the finish options. I'm working on a private residence for one of the world's wealthiest men at the moment, and we're looking at a very unusual customized finish. And in this location, it was determined that a highly corrosion resistant duplex stainless steel was the way to go. But the architects haven't considered its forming limitations, and were asking for a bend that's too tight for that alloy, and there's a risk of cracking. So we're having ongoing discussions about how that design needs to be modified. So it is important to understand upfront what the forming limitations and design limitations might be for a given alloy. All stainless steel is silver inherently. And this, some of you may wonder why I'm bringing this up, but I do regularly get questions asking if the base metal color can be changed to a copper color or something else. Perhaps it's because the person that's asking is thinking of some of the plastic products where you could abrade the surface and still have the same color. But with stainless steel, it's silver. It is important to understand that a specific alloy, let's see, type 316, from multiple suppliers will fall into the same chemistry range, and it will be the same inherent color. The finish could look different because of the different processing steps. So you could have multiple suppliers, but every processing step in applying the finish has to be the same for the final finish to match. Larger alloying differences can mean slight color differences. So, for example, if you go from a ferritic to an austenitic to a duplex stainless steel, if exactly the same finish is applied, then there is a slight color difference that could be apparent in an exterior application if those different alloys alloy families are side by side. I should also mention that's also true of different alloys within the same family, or weld metal for an alloy. It can be a slightly different color because it's more highly alloyed. And I'll talk a little bit about that later in the presentation. If you are ordering sheet, then asking for a stretcher or tension leveled quality of flatness can be very important so that it's very flat before a finish is applied. If it isn't flat and a finish is applied to it, like a number 4 polish, then the resulting appearance may look wavy, even because of how those polishing belts are hitting the stainless steel surface. For alloy product forms like bar, for example, that can have higher sulfur, it is important to chemically passivate the surface. For sheet and strip and other product forms, specifying low sulfur can help when you have a mirror finish, because otherwise small sulfides in the surface as it's polished to a mirror level can look like little pinholes. So chemistry can make a difference. Asking for the stainless steel to be chemically passivated or requiring the supplier to confirm or certify that there is not going to be any iron contamination on the surface is another step. There are tests that can be done to certify that. We also want to quantify the finish whenever possible. Referencing a finish by name isn't enough. The descriptions in the international standards are too vague for an aesthetic application, and that's part of what I'm going to talk about. I do want to point out that you could have 2 different number 4 finishes, and differences in how those are applied can mean a big difference in corrosion resistance. And these pictures are both type 304 stainless steel exposed to exactly the same salt spray test. There is a lot more corrosion on one sample because the surface is rougher, it's not cleanly cut, and under a microscope, it's clearly torn. So finish application is important. This is another very wealthy person's house that I consulted on in Florida. I think his pool house was larger than my house. It is on a peninsula and it is very close to sea level. So whenever there is a hurricane coming through, the base of this house can be immersed in salt. And I took a look at it after 3 direct hurricane hits where salt water was splashing up to the higher levels. Everything is type 316, and there was some light staining on it. And I was called in to find out how to clean it up. It really wasn't that hard, but it would have, at least for the levels that were likely to be immersed, such as the base, a higher alloyed stainless steel might have been a good idea because it would have prevented a lot of cleanup. So the consistency of finishes is critical for appearance. Bare metals are not the same as paint. You are never going to get something that is a perfect match, but you can work with a supplier to quantify. And that added communication helps everyone. So the supplier knows what you need, and you make sure that you get what you ideally want. So one of the primary means of documenting finishes, quantifying them, is the surface roughness RA, which is an arithmetic mean average of the surface finish. And I'm showing that on there. You basically take half the peak height and measure that. And it is important to note that the color, or at least what we perceive as color, closely relates to the RA value, in addition to it relating to the chemistry. So, RA is a very commonly used finish, and ideally you want to set a range that is acceptable to the supplier, but also to you. And then you want to, if you're a specifier, look at a couple samples that represent that range in whatever your lighting conditions are going to be, and then agree with the supplier about that. And this is done all the time in the appliance industry and other consumer products, where you have to have close matching, as well as in architecture. I do want to point out that in addition to RA, there are other measurements of surface roughness. For some projects where I'm working with a supplier to try to obtain consistency, RZ can be very handy, and it depends on the finish as to which measurements you might choose, or RT, but there are many measurements that can be taken, and it's good for the supplier to understand their finishes and how these numbers might vary so they can obtain consistency as well. RA is also closely correlated with corrosion performance. Doesn't give you, 100% prediction, but it does give you a good idea of what might happen. And I have shown on either side of the line here some of the finishes that typically fall into those that are less than 0.5 microns and those that are greater than 0.5 microns. That's kind of a magic number, because once you are above 0.5 microns, we see a rapid increase in corrosion rate. So if you've got a corrosive environment, whether it is industrial or perhaps inside an exterior environment where you're going to have salts or pollution exposure, or anything where this might cleanability or corrosion is an issue, you generally want to stay at a finer finish. Hairline, for example, or vibration, some of the rolled-on finishes are all in this range. A number 4 polish can either be smoother or rougher than 0.5. It depends on the supplier. But you do want to quantify it and talk to the supplier about this. Reflectivity has become a very hot topic, and there's several ways of measuring reflectivity. I'm going to talk about the most common means of measurement. The requirements for building exteriors vary depending on where you are around the world. And then, of course, for other applications, the specifier has to decide what's most relevant. One of the most common measurements of reflectivity is specular gloss. And sometimes when people say reflectivity, this is what they mean, but it is important to clarify that. The studies on specular gloss and its measurement, I believe, go back to the 1940s, to the earliest specifications. This is measured at different possible angles, and you choose this angle based on the type of finish that you have. There is a formula. If you were above, certain numbers, then it automatically indicates whether you need to be at 20 degrees or 60 degrees in terms of measurement. Most stainless steel finishes are measured around 60 degrees. But if you have something that is very high gloss, a mirror-like finish, the correct angle might be 20. So, and here I'm showing how the beam impacts the surface and whether it is diffusing light or just reflecting it directly back outward. There are two other very common units of measure, as specular reflectance, sometimes called RSpec. It's similar to specular gloss, but it is focused on the total emitted light that is reflected from the sample. I'm showing a diagram of that. Then there's also diffuse reflectance, or haze. And this is a measure of how much of the light is diffused or reflected at different angles as compared to a perfect mirror. So when I'm working on a project, I have a tool that I use that will give me all three of these measurements. And then I will look at them to categorize a finish. So it really depends on the type of application as to what you would use and how sophisticated it might be. You may have heard of glare regulations. Sydney was the first to impose glare regulations, and then Singapore adopted them for facades. This is based on specular reflectance, and Singapore requires all facade materials other than glass not to exceed 10%. So it's a different measurement, and it does use an ASTM spec as well as DIN specs, and these are some of the same standards that are used for solar panels. When I first started trying to understand this in more detail, I called up my nephew, who's an electrical engineer working in alternative energy, and he sent me the standards so that I could better understand what they meant. So this requires a much more sophisticated testing equipment than the typical gloss measurement, typically done by a lab. As I am only aware of one supplier who has created a stainless steel finish capable of meeting Singapore's requirements, which are very, very challenging. And Urukumpo kindly shared this chart with me. And I, yes, these are their finishes. And perhaps there are others that have developed finishes as well. But as far as I know, this is the only one. And it was quite a process for them, from what I understand, because of the need to diffuse the light so much to get down to this level. I think that's part of why so much painted metal is being used in Singapore for building exteriors. I'm going to talk about some colored finishes. And if you are specifying a colored stainless steel, then you should also be measuring the color. This is a fairly simple color test unit. There are some that measure it directionally and others in, in all directions simultaneously. But you're not going to ever obtain as consistent a color with stainless steel as you would with paint. It's like anodized aluminum. It's going to there's going to be some natural variation, and that is part of the beauty of stainless steel, unless of course you are painting stainless steel, which is done. So I mentioned sulfur previously. The cloud gate is stainless steel plate type 316 with a 0.001 sulfur level. Bar, tube, and pipe can have higher sulfur levels. So if the cloud gate had a high sulfur stainless steel, still within the specification, but higher in sulfur, everywhere where there was a sulfide on the surface, you would have seen a little tiny pinprick. And it wouldn't have looked nearly as attractive as it does because of those sulfides. Those sulfides also can, if you have a higher sulfur stainless steel, be places where corrosion can initiate. So there's more than one reason to consider a lower sulfur stainless steel. For most aesthetic applications, you'd want to be at 0.005% or less, and most stainless steel production falls in that range unless the stainless steel is specifically being made for an application where a higher sulfur level is required. So welding is a great fabrication method, but it also destroys whatever finish you have. So if you're paying for a very fancy finish, but are planning on welding, please do understand that that weld area will not have that finish. Applying the finish after fabrication or using a mechanical assembly may be needed. So I'm showing the cloud gate again, and this is again something I consulted on. When they started to weld this together, the fabricator realized as they polished this to a perfect mirror on those welds that there was a color difference and the welds were showing. That's because weld metal is more highly alloyed than the metal that is being welded. So they had to have a welding product supplier do some experimentation and come up with a weld metal to match the base metal, because otherwise we would have been able to see all of those weld lines. They would have been faint, but they were there. To obtain a uniform finish, it's important to use ideally use one coil or consecutive coils from one supplier. That doesn't always happen. In the appliance industry, there can be multiple suppliers getting stainless steel from different places. And in that case, they are very careful about making sure the finishing steps are the same and have very careful surface roughness and other tolerance ranges. Marking the rolling direction is also important. The top image shows pieces cut from one sheet of stainless steel. If you turn a panel 180 degrees, the color will look different if you have a directional finish. Also, numbering panels is important because from one end of a coil to another, there are going to be slight amounts of roll wear or polishing belt wear that can cause finish variation. So if you want the maximum level of consistency, that should be considered too, especially if something's going to be out in bright sunlight. It may not matter inside a building, unless it's perhaps in, there's a lot of natural sunlight coming in. The bottom picture is a civic arena in the United States, actually Pittsburgh, where I live, where the stainless steel was provided by 4 different suppliers, and it's just a mill finish. So they were never going to match. We have a lot of rainy, gray days in Pittsburgh, and on those days, you can't see that variation. Here's another example of what happens when panels aren't all in the same direction. And of course, this is inside a bank building. I'm not going to identify where it is. I'm going to focus on finishes that aren't in specifications because I think you need to specify more and understand that simply calling out a name may not be enough. Rolled on finishes or coined finishes are a one-sided pattern. This is a finish that simulates abrasive blasting that's been commonly used for roofing applications. There are many suppliers around the world who have finishes like this. The advantage over abrasive blasting is that it can be on quite thin panels. It also is more corrosion resistant than a finish that is actually abrasive blasted. Because at a microscopical level, you have a smooth rolling finish as opposed to one that's more jagged, like abrasive blasting. You might think that this variation in color is caused by somebody turning these panels around 180 degrees. That's not the case. This is on, well, a very large airport roof. And after I did some measurements, it became apparent that there was a difference in the pattern depth. Apparently the supplier had rolls, but was not replacing the rolls that applied this finish frequently enough. And then the installer had the coils mixed up. So they were mixing up coils, 1 with coil 10, and more coil wear had occurred. So there was a pattern depth difference, and that caused this variation. By pure luck, they happened to have these every other panel, and I think the architect came up with a story about it being design intent, but it wasn't. The finishes that are sometimes called an 8, 9, 10, 11, 12, it depends on who's selling it as to what they call it. Finishes that are a perfect mirror, are not covered by any of the standards. They are very smooth, and they are achieved by buffing, sometimes for as long as 60 minutes. They can either start with a bright annealed finish and buff it, but that can leave some imperfections. For something that truly has to be a mirror, you usually abrasive polish to get rid of any surface imperfections, and then buff, sometimes for as much as 60 minutes. The hairline finish was first developed in Japan, but has become very popular around the world. It is a directional, long, fine, parallel line finish. I was told back in the 90s when our first trip to Japan that this was called hairline or long grain, because it looked like a woman with long straight hair, in terms of pattern. So this is applied with non-metallic abrasive pads, often Scotch-Brite, either by hand or with equipment that does it. And this makes it actually quite repairable relative to a number 4 finish, because all it takes is someone with a steady hand and to blend in the finish. With a number 4, you have much shorter grain lines, and usually that has to be completely refinished if there's scratching. This is also usually a finer finish. It has a very consistently lower surface roughness than a number 4 might. The vibration finish is a non-directional scratch pattern. There are many different proprietary product names like angel hair and suede. The scratch lines can vary from short to long. The density of the lines can vary, so they can look very different. Here are 2 examples. If this is a finish that you'd like, then it is very important to make sure that there is a visual standard, but also as much quantification as possible, so that if you are going out to bid, that everybody understands what you're actually requesting. There are many different ground finish patterns applied with grinding wheels or coarse stainless steel wire brushes. These can be applied on cut sheets by computer-controlled equipment, or by a worker using a grinding wheel to create a pattern. Again, it's important to have a very concise, very accurate description of the finish, but also a visual standard. These can vary in their level of reflectivity, and if you have it manually applied, if the worker applying it had a long night, maybe a young child was waking them up all night, then they might not be able to hit that same pattern without a good standard sitting beside them. I have heard that some places that apply these by hand often put on music to motivate the operator. So it is important to understand that these are very coarse scratch patterns, so they are going to be much more susceptible to corrosion if they are out in a corrosive environment. They will also accumulate more dust and dirt than the finer vibration finish that I shared previously. Here are a few examples of some of the things you can do with mechanically grinding surfaces. These are from a company in the US called Maine Steel. They have created finishes that look very three-dimensional, but are flat with using different grinding patterns. Abrasive blasted finishes are non-directional and they are repairable. But if I had $10 for every time I've had a fabricator call me and say, oh, I've distorted all my panels, how can I do this correctly? I probably would be retired by now. For thin panels, abrasive blasting without very careful fixturing can cause panel distortion. There are suppliers that apply abrasive blasting to coils under tension with backing, who supply quite flat material. But for most applications, a fabricator wouldn't want to just abrasive blast a thinner sheet of stainless steel. It is a very good and inexpensive way of getting a uniform finish on a structural section. It is important to understand that this is a rough finish, so it can have more issues with corrosion. Pickling it afterwards can help with that a bit. It will show fingerprinting, and anything like markers or paint, anything that might get on an abrasive blasted surface can be difficult to remove, especially if it's a very aggressive abrasive blasting pattern. So there are different media that are used. The rougher the surface, the more susceptible it is to corrosion. Fine sand and silicon carbide, which tend to produce a darker, coarser finish, are also tend to have the most problems with corrosion. Glass beads or stainless steel shot have a surface that is more smoothly rolling under magnification, so those are less susceptible to corrosion, but it's still a rougher finish. So you have to consider what's appropriate. This is abrasive blasted stainless steel that was used to clad a former industrial building in Switzerland, which was made into a museum. The U.S. Air Force Memorial, which used 19mm plate, is another example of abrasive blasted stainless steel. It was actually a three-step finish. The stainless steel plate was first ground to get a very consistent appearance, then abrasive blasted, and then pickled, both to dull the finish, but also to help with corrosion resistance as well. Electropolishing smooths the surface. It's an acid treatment. It generally reduces the surface roughness by about half, but that can vary. And it's often used on a surface that has been mechanically polished by a number 3 or number 4 polish to smooth it. When otherwise handwork would be needed, or it's a surface that is to be challenging to polish. Their door handles and artwork and a variety of other surfaces are often electropolished to smooth them. Acid etching is used to create signage, but also decorative finishes on stainless steel. The area that you want to have remain with the original finish is masked off and then the bare areas are etched to recess them. It is quite an art, and without experience, it's easy to undercut and get less crisp lines. So going with an experienced supplier is important. It's also important to note that permanent fingerprinting can be a problem in the etched areas because those are quite rough. So if you have, say, someone whose hands are dirty, perhaps they have something acidic on their hands from lunch, and they touch these etched areas, and if that is then sitting out in the sun, that can cause further modeling that becomes permanent. Perforated stainless steel is used for many different applications. These are decorative panels over what was otherwise a glass security door, just to create something that was more visually interesting. This is an interior stair at Bangkok International Airport. I was given construction images, but you can see perforation at the back of the stair. More examples ranging from a very elaborate multi-layered sunscreen to pieces of art and other decorative elements. When you are perforating stainless steel, there are a couple ways of doing it. One of which is punching, and I'm showing a picture of that. If the punches are not new, and where the stainless steel is too thick, you can get a rough, jagged edge, which can be a place where corrosion can start. Laser jet and water jet cutting are used as well. Those generally give a cleaner line. I'm also, showing woven stainless steel, and I'm going to show some examples of it. It can be a wonderful design medium, but it is full when you have wires or strands of stainless steel that are overlapping, then you have crevices. And so it's important to make sure you're using an alloy that is appropriate for an environment, and has adequate crevice corrosion resistance. So woven stainless steel comes in a broad range of patterns and styles. It's sometimes combined with other metals. The bottom picture shows stainless steel with a copper alloy. As mentioned, you have to consider crevice corrosion, which for stainless steel is really more of an issue where there's salt present. But it is impact resistant, and it's being used for a broad range of applications. There aren't any standards for this for architectural applications. The only woven standards are for things like mesh that's used for screens. There are a couple different ways of doing it. There's expanded metal mesh, which doesn't have the overlapping areas. There's welded mesh, and then there's woven mesh. Anything that has tight crevices, then that should be considered. This is an example of woven stainless steel. It's being used for sunscreens. This is the Second Children's Activity Center in Guangzhou. This is what it looked like brand new. There's a lot of pollution and airborne dust in Guangzhou, and so it is unfortunately much dirtier now. if there were power washing on a regular basis, that would help. But you have to consider the environment and what it's likely to look like over time. I don't have a picture of it now, but it is much dirtier because of the high level of particulate in the air. Here is an example of it being used for sunscreens, and then used as a support for plant screens for sunscreens. Here's another sunscreen application. It's become quite popular for that application. And these are rolling shades, which are another use. I just wanted to show a few of these. There are also some slat designs, which could be pieces of cut strip as well. Embossing and coining, there is an ASTM standard A947M, but it is really geared towards industrial applications like conveyor belts, where embossed stainless steel is commonly used to move product. The top image is a coined stainless steel. So that is a coil that has been passed through rolls where one is patterned and the other is smooth. So if you were to flip that panel over, you would just see a flat surface, and versus the front, which has a very light pattern. With embossing, both rolls are patterned. So you have truly a two-sided pattern. The light patterns will increase the rigidity and impact resistance by 10 or 15%, while the heavier patterns up to as much as 35%. If you're concerned about impact resistance, for example, column covers at an airport or some other high traffic facility, then a heavier pattern should be something to be considered, because that could allow you to use a thinner piece of stainless steel while still getting the impact resistance that's needed. This cold works the stainless steel, which is why you get this strength increase, and that helps to hide scratches. So if it's an application where that's an issue, then that should be considered too. Embossing and coining can be customized. It's become far less expensive than it used to be to create customized patterns. So, and this is custom embossing, a dot pattern combined with a non-directional ground pattern. They also are combined with paint and electrochemical color. There are a lot of different combinations that can be created. Coined stainless steel is one of the most commonly used finishes for building exteriors. And the pattern certainly is attractive, but the big benefit is its ability to diffuse light. Applying a pattern will automatically scatter the light. Of course, it will really depend on the underlying finish as to how dull or bright it might be. So the one finish that has met the requirements of Singapore to date is one that has a very dull substrate with a pattern applied to diffuse the light. In comparison, these are embossed patterns applied to very reflective, bright annealed surfaces on the top, and a duller 2B mill finish on the bottom, which is just to create a sunscreen. So Zaha Hadid's Broad Museum of Art uses corrugated stainless steel panels, which is another form of embossing. There have been some very interesting projects using essentially fancier corrugated panels. Gary Partners has used corrugated stainless steel, as have a few other firms, to create some very interesting effects, and it can be cost effective. Electrochemical coloring is one of the means of applying color to stainless steel. It is similar to anodizing aluminum. It thickens the transparent chrome oxide that makes stainless steel stainless. And as that transparent film is thickened, it filters out wavelengths of light. It's the same thing that occurs when aluminum is anodized. And that's why it's sometimes called light interference coloring. And thicker films give you darker colors, and and you can get either very consistent color, and this is electrochemically colored stainless steel combined with embossing on the back of that sign. Here are two examples of very uniform color. You can get practically any color possible, but it's important to understand as you change the angle of viewing and as lighting conditions change, then the color will change. The center picture is a museum in Australia where they angled the panels so that different times of day, you see different colors emerging on the building. I should note that this is not ever going to be as absolutely consistent as paint. So you have to be able to appreciate the fact that this is a living color. I believe that the Gary Partners first coined that word, but I may be wrong. To talk as it was used for a museum that he worked on. This is the Shakoden Temple in Japan is one of the earlier applications of electrochemically coloring stainless steel. It was completed in 1975. I had a chance to take a look at it about, I think it was 2002, and took the top right picture. I was subsequently, a few years ago, sent the bottom right picture. It hasn't changed in all of these years. But part of this is cleaning the roof and selecting an alloy that is appropriate for the environment. As I showed earlier on, if the wrong stainless steel had been used or it wasn't cleaned, then this color could have disappeared over time. And that's happened on some buildings. Here's another example. They wanted color variation, and you can see that on the shingles on the building. Here's Neiman Marcus is a very high-end department store chain in the United States. They used different variations in color to create this pattern, but it also varies with the angle of viewing. The Experience Music Project, which was a Gary project, because was the first project I ever worked with them, has this purple building as one of the facades. And in some times of day, it looks solidly purple. This was taken closer to sunset, and gold tones are coming out. So it, it will vary with the time of day and the angle of viewing. Here are some more examples of deliberate color variation with this coloring process. Plasma vapor deposition has become increasingly popular. It's the application of a thin adherent ceramic layer to the surface. The color is determined by the ceramic that is applied. So gold is titanium nitride, black is titanium carbide. There you can obtain blues and browns and a whole range of different colors. There are quite a few projects out there where stainless steel is being used instead of copper alloys, because you don't have to worry about color change and maintaining a coating on a copper alloy to retain the color. The bottom left shows this finish applied over an etched surface. So you can see that the etching is still visible. The Burberry store in Chicago is the bottom right, and there's both black and gold bands with this finish. So this is applied by placing a clean stainless steel panel in a vacuum chamber. Quality control is critical. The surface has to be clean going in. You have to have all the right processing steps to make sure you get good adherence. This is inherently a porous coating, and because of that, to get both better corrosion resistance and better color consistency, a good supplier will put down a layer of pure titanium with then the ceramic layer on top of it. And that double layer is similar to applying multiple layers of paint. And of course, the titanium has a high level of corrosion resistance. So it also serves as a mirror, so it reflects back the color and gives you more consistency. So it is important to ask questions of the supplier and have quality control in place. When I consulted on the vessel at Hudson Yards, we instituted a great deal of quality control. My father is a metallurgist as well, really more of a physicist, and his area was thin film, so I actually knew how to use sputtering equipment when I was still in high school. So I got to use some of that old knowledge on this project to set stringent requirements for the suppliers. Paint is applied to stainless steel. It's more common than many people realize. Stainless steel buses are very common around the world, and they're usually not, you usually don't see the stainless steel. They're usually painted. In Japan, a fairly large percentage of the roofs are stainless steel, but they paint them. So it's not hard to paint stainless steel, but it is like painting aluminum in that you have to make sure the passive film is removed immediately before the paint system is applied, or at least the primer is applied. Otherwise, the paint can peel off. painted roofs are pretty common in addition to transit. This is a stainless steel train that that's painted. I should point out that well, the first painted stainless steel that I am aware of anywhere in the world was work done in the U.S. in the 1960s. There may well be earlier examples. This happens to be fairly close to where I live. That used to be blue stainless steel, and the paint failed. They chose to simply remove the paint. I know of several buildings in the Pittsburgh area because of the early work done by PPG, a big paint supplier in this area, on painting stainless steel. So make sure that the stainless steel is corrosion resistant enough for the environment. And then, even if the paint fails, it can continue to be used, or potentially it can be repainted. I'm also showing an aluminum roof. When other painted metals coatings fail, you then typically get corrosion of that underlying metal. So that is an advantage of stainless steel. Even when the paint fails, it can potentially continue to be a useful building. Kuala Lumpur International Airport had a custom painted stainless steel roof. Gray and black color has become very popular among architects in some parts of the world. There are a variety of ways of achieving it. The best options are electrochemical coloring, PVD, and the tin and the tin zinc coatings are pretty popular. So the top right is an electrochemically colored stainless. The bottom right is a museum in Japan where they applied zinc to plate and it's spangled. The bottom left is turn coated, a tin zinc coating on stainless steel at Carnegie Mellon University in the US. There are coloring methods to obtain these colors. It should be used with great caution. Chemical blackening without hardening has been used by some suppliers, and in an exterior application, it doesn't tend to last very long. Some suppliers will use the same chemicals that are used for electrochemical coloring, but without the series of chemical tanks. So they'll just put them on the surface, and that can be more readily rubbed off or simply removed by rain. Gunmetal blackening, as is done with weapons, is used on stainless steel. The problem is that usually oil is applied when it's a gun, and that would just wash off outside for a building exterior. Once that oil is removed, if you really look at the surface, it's not very uniform in coloration. It also, these chemicals also reduce the corrosion resistance of the stainless steel. So there are a number of things that you need to be aware of. I'm aware of a building in the US where the architect was sold on the idea of using gunmetal blackening for the exterior wall panels, and they didn't stay black or consistent for very long. Abrasive blasting with sand is also used to create darker finishes, but as mentioned previously, that can substantially reduce the corrosion resistance. I am regularly asked about the Yale Center for British Art because it is such a famous building, and I have some pictures of it. I think that some of the pictures that are most often seen are those of it when it's brand new. This is stainless steel plate that was heat treated and not pickled. It was done by British Stainless, a precursor to what's now Outokumpu, at a mill in the UK, and shipped over to the United States. The actual building now is far less consistent in color than the old pictures that are out there, because it was, the scale is gradually wearing away or falling off. And it's on the basement of it, it's corroding because this substantially reduces the corrosion resistance of stainless. On the inside, it looks fine. And you can see what it looked like when the exterior first went up. So there are a variety of coloring methods out there. Many finishes can be combined to create a variety of options. And with that, I'm going to give you a chance to ask questions.
I, I think we have some questions. So, Rahul, will you please read out the questions?
Yes, sir. The first question is from why it is not a preferred selection in the market.
Can't hear you, Rahul.
Why special finish is not popular in the ABC industry and why it is not a preferred selection in the architecture industry. Hello. Sir, am I audible?
Yeah, repeat the question along with the name of the person who has asked the question.
The name of the person
I can't hear. I don't know
the name is Vishal Kumar.
why the questions are being asked.
And the question is why special finish stainless steel is not popular in the architecture, building and construction industry.
Get the question, Catherine? Catherine, can you hear me?
Okay, I'm not hearing you. I'm not hearing anything.
Okay.
I'll do one thing. Hear me, Catherine?
Catherine, can you hear?
I can't hear. Can you hear me?
Yeah, we can hear you.
Okay. Should I read the questions then and respond?
Yeah, the question is.
All right. So okay, I see a question. Please enlighten us for the measurement for vibration appearance. So for vibration finishes, a surface roughness range is one option, as well as measures of reflectance. Gloss would be pretty typical. Because they can vary so much in appearance, I would usually suggest a discussion about scratch length and the density of the scratch lines. And let's see. I see another question about the life expected on the colors that are applied to stainless steel, either electrochemical and PVD, in how it varies in performance. So, the PVD is more abrasion resistant than electrochemical coloring. So if that is a factor, then PVD is superior. It is also more consistent in color. There have been some famous examples where electrochemical coloring was used in the Middle East or along a shoreline where sand abraded away electrochemical color, or where pedestrians abraded it. So it is less wear resistant. When it comes to corrosion resistance, it is then a matter of how the finish is applied. If the PVD has a good layer of titanium underneath, then it can have a good corrosion resistance. With electrochemical color, if you have even an environment that's slightly too corrosive for it, you can lose color and without having significant staining. So you usually have to go with a more corrosion resistant alloy. I'm hoping that I'm answering everyone's questions. So let's see. Apart from chromium, molybdenum, I think that I'm having trouble reading it. My eyes are tired. Nitrogen. What are the other elements that help to enhance PREN? Well, I mean, those are the elements that are included in the calculation, and it really then is a matter of there are different multipliers for different elements. So let's see. As I understand, coating on stainless steel surface, can it prevent corrosion? So is there any limit of coating thickness on the surfaces of austenitic stainless steel, ferritic stainless steel, etc.? I'm assuming, I'm not sure what type of coating. If it's paint, then you can apply a standard metal multi-coat finish. And that's typically done in a more corrosive environment. The PVD and electrochemical color wouldn't necessarily increase the corrosion resistance, as I've mentioned. After polishing on stainless steel coil plate by using abrasive belt followed by pickling passivation over a period of time, it turns into a brownish shade. What could be done to avoid that brownish shade and retain the original polish? So if you were getting a brownish red shade, then that to me implies that there might be some sort of cross-contamination happening, or the surface is rough and the environment is corrosive, and that is adding to it. It's I would suggest perhaps speaking to ISDA a bit more about what you were seeing and perhaps sharing some images and a timeline, because the cause I mean, it could be iron contamination if it happens very quickly, and if it takes longer, might be a matter of how that finish was applied and how rough it is. There can be other factors too. Let's see. The color coding through PVD improves the corrosion resistance. In that case, can ferritic grades be considered over austenitic and less demanding under the shade application? So PVD is inherently porous. You can improve its corrosion resistance by placing a layer of titanium underneath it. That also improves the color consistency. I generally would not advise using a stainless steel that isn't corrosion resistant enough for the environment, because if you have porosity that lines up where there's a pore in the top color layer, but also in the titanium, you could end up with crevice corrosion. So I always suggest using a stainless steel that's appropriate for the environment. And that could be a ferritic, as there are certainly ferritics that you know, range from being low in corrosion resistance to seawater stainless steels. Let's see. Which finish in stainless steel is better to improve the solar reflective index to minimize the temperature of the roof of the building? That's a tricky question, because with solar reflective index in LEED, there are limits to what is permitted for a roof, so if you have, and it's dependent on the slope of the roof as to what those limits are. For a low slope roof, it's almost impossible to hit those requirements unless the stainless steel is painted, or you use the stainless steel as a base for a vegetated roof. For a higher slope roof, to hit those limit requirements, you usually have to use a rolled on finish that simulates abrasive blasting, something that really diffuses the light to meet those reflectivity requirements. And I've seen numbers for ferritics and austenitics, and with these types of finishes applied, and I've actually have seen it for duplexes as well, and they all can be applied to meet those requirements. And unlike the other finishes, there are some long-term examples where stainless steel roofing has been used and it retained the SRI. One well-known case study is a large convention center in the United States, and 20 years after it was installed, they measured it again, and they found that they could actually that there was no change in the SRI. So at most, you'd have to clean it to retain it, while a painted finish has to be repainted perhaps every 5 years to retain that value. Let's see. Let's see. Hi, Catherine. Wish I received the information about chemical blackening earlier. I have some stainless steel that already developed rust after it was exposed to external weathering. Is there some way to save some kind of save for such a situation? If it's already installed, then there really isn't a good way of achieving black after that's deteriorated. The best option might be some sort of a field applied finish, or if they truly want black, then consider painting it. Unfortunately, I wish I had better news for you. So let's see, how to address the weld joint area for color-coded material. If you, I'm assuming that well, you can't weld after coloring. So if this is coloring after welding, then for PVD, with a titanium layer you could hide that. With if you're talking about electrochemical coloring, that slight color variation could potentially show through. But if you have a finish that is applied after welding, that perhaps a vibration or something else that just changes the surface texture, you'd be unlikely to see it. So, which type of abrasive is suitable for grinding, and what is the grit size? That would be, it really would depend on what your end use application is. And sometimes replacing the abrasives regularly can be more important than the abrasive media. So generally silicon carbide will cut more cleanly than the aluminum oxide. But if the belts are replaced very frequently, so they aren't worn, then they will cut more cleanly, and that will give you a better finish. And if you're simply trying to get a high level of corrosion resistance, you usually work up from perhaps anywhere from a 60 to 80 grit up to perhaps a 180 or 240 grit. As you go to a finer grit, wet polishing in combination, will give you a much finer finish and a more corrosion resistant finish. Why is only gray electrochemical color possible in ferritic stainless steel? So that is the chemistry matters in this case, and nickel levels turn out to be quite important for electrochemically coloring stainless steel. And it's interesting because I've been involved in a project where duplex stainless steel had to be colored, and it's turned out that the higher the nickel level is, the better, more easily a stainless steel can be electrochemically colored. And I'm not just saying that because the Nickel Institute is a sponsor. So let's see. Trying to see if there are other questions on the screen that I haven't answered. And I have no idea what the best abrasive belts are in India, but perhaps somebody at ISTA can help with that one. I don't see any more questions, and I'm not sure why I can't hear anybody.
Thank you, Catherine. I think if there's any more questions, the delegates are free to write to us and we can share with you. Because we have a questionnaire option on our website where we welcome any kind of technical queries which we would like to answer either by ourselves or with the help of our members and partners. So you're always welcome to raise your query anytime. So thank you, Catherine, for that wonderful presentation. I think it was very useful, and these finer points will make us, know how to use stainless steel better and make it valuable. George, you have anything further to say?
No, I would like to thank as well Catherine for this amazing presentation, and of course to ISTA and all its staff for the setup of this webinar. And I really hope that we can have in future again a few more of these interesting topics for the architectural and building industry. So thanks a lot for everybody who joined in, and handing over to you, Karan. Thanks.
So thank you very much. Thank you all the delegates. Thank you, Catherine. Thank you, Team ISDA, for all the trouble that you have taken, and wish you all the best. Stay safe. Bye-bye. Thank you.
Thank you. Goodbye.
Bye.